Alrighty, good morning or good afternoon, ladies and gentlemen. Happy Wednesday. So this is our last section for Chapter 5. 5.5 is our chapter review. So this is be the last major lesson for this unit. There's going to be a test on it when we get back, so that's next Thursday. So we have about a week until that time. So expect another assignment on how to do for 5.3 and 5.4. And then sort of a review package or a review assignment. And I'll spread that out over the next couple of days so we have a chance to do that, as well as having our logic check-in puzzles. On Friday, I'm going to make a video talking about two different types of reasoning that we can use to solve these puzzles. It's more of a general rule rather than a specific one, and you've been probably using them without knowing about them beforehand. But anyways, I'm getting off track. Today we're going to talk about dividing polynomials. So if you remember last class, we talked about multiplying polynomials. In this case, we're going to divide them. So first off, I want to do a bit of a recap with an example here. Now, this is an example of basically two polynomials. On top, I have four terms. I have a plus 4, plus 2, plus 6, negative 8. At the bottom, I've got a constant. I've got just 2, and I'm dividing the two by each other. So there's two ways that I can go about solving this. So method 1 is I can add up everything on, so add up top first. So this is sort of like our bed mass, so I would do 4 plus 2 plus 6 minus 8. So I get 6 plus 6, which is going to be 12. Take away 8 is going to give me 4, and I'm going to divide this by 2. So all I've done is simplified this top piece, and then I have 4 divided by 2, which gives me an answer of 2. The other way I can think about this is this divide by 2 is applying to everything. So another way I can write this, if I go down, I could write this as 4 divided by 2 plus 2 divided by 2 plus 6 divided by 2 minus 8 divided by 2. And it seems weird that I'm doing this, but you'll see why when we get to polynomials. So then I simplify this down, so I'll keep going down. So 4 divided by 2 gives me 2. 2 divided by 2 gives me 1. 6 divided by 2 gives me 3. And 8 divided by 2 gives me 4. And I remember to bring the negative sign down. So now I have 2 plus 1 plus 3 minus 4. So what if I plug this in, I'll get 2 plus 1 is 3, plus 3 is 6. Minus 4 gives me 2. So in both cases, I end up at the same answer. Now, why this is important? We're going to be using this method. So use this for polynomials. And kind of the question that I might expect is why now we have unlike terms. That's basically the key bit. If I have 4x minus 2, I can't do anything with them, so I can treat each of them separately and simplify my equation that way. So that's exactly what they did here. So in the example in your book, you start with 9x squared minus 3x plus 6. So the top polynomial is already simplified. They're all unlike terms. So I can't combine anything. And they're also from highest degree to lowest degree. So on its own, I can't figure out what that is as one number like what I was doing up here. Instead, what they're saying is take the 3 and divide each term by the 3 separately. So then you end up with 9x squared divided by 3, take away 3x divided by 3, and 6 divided by 3. And again, dividing by a number, or I'll say a constant, affects the coefficients and constants only. So what I mean by that is I have 9, I have 3, so I divide the 2 and I end up with 3x squared. So I haven't touched the x squared. It doesn't change that at all. I'm just changing the number out in front. Take away 3 divided by 3. So I have 3 and I have 3. So this is going to give me, whoops, negative, there's a little 1 here. And then lastly, 6 divided by 3, I'll use a different colored ink. I'll use dark green. So this is going to give me 2. To show a slightly different example, because this has 2 examples using 4s or negative 4 and 3. Let's say I do something different and I have 7x squared plus 14xy minus 21y squared, take away 49, and I'm dividing this whole thing by 7, positive 7. Actually, let's do negative 7. I'm feeling adventurous. So again, what they're saying is apply this to everything. So I have 7x squared divided by negative 7 plus 14xy over negative 7 minus 21y squared over negative 7. Take away 49 over negative 7. So if I go through each of these, 7 divided by negative 7 gives me negative 1, which I'll write as negative 1x. Positive 14 divided by negative 7 is going to give me negative 2xy. Negative 21 divided by negative 7, I have 2 negatives, so this is going to be positive. So this is going to be 3y squared. And then lastly, negative 49 divided by negative 7 is going to be positive because there's 2 negatives, 7. And then lastly, if I need to, I can clean this up a little bit. The one thing that I see is I can get rid of this 1, so I can write it as negative x squared minus 2xy plus 3y squared plus 7. And as a reminder, all 3 of these have the same degree, so I'm working alphabetically. I'm starting with my highest value of x, and then I switch to my xy's, and then I go to my highest power of y, and then I keep going down. So there's no degree 1, there's just a degree 0 with my constant. So this is my final answer written math grammar properly. So grammatically, in terms of our math language, this is the proper way of saying it. Okay, and that's if we're dividing by a constant. What happens if I instead divide by a monomial? So something like, as a reminder, a monomial is something like 4x or 3y or z. So now, what do we do when we have a variable? So as a recap or a recall, I'll say, if you think back to one of our first units, we had the power rule. So previously, if I had, say, x to the 2 times x to the 3, we said that it was equal to x squared plus, or x to the power 2 plus 3, so this would be x to the 5. I added my powers. If instead I had x cubed divided by x squared, this was the same thing as 3 minus 2, so I take the top power and I subtract the bottom power, so this would be x to the 1. The other way you can think about it is there's 2 in the bottom, it cancels out with 2 on the top. So another way I can write this is this would be x times x times x divided by x times x. So this one and this one cancel out, and then this one and this one cancel out. So all I'm left with is x. So we're going to use this in combination with what we've just learned. So, for example, here they have divide negative 9x squared plus 6xy by 3x. So the first thing that they've done is they've combined, or they've split it apart and created two different divisions. And you're going to do this in two different steps. You're going to divide the numbers, so negative 9 divided by 3 is going to give me a negative 3. The bottom x is going to cancel out with one of the top x's, so I'm going to be left with 3x. Pardon me, negative 3x. Positive 6 divided by 3, so I have 6 divided by 3, so this is going to give me positive 2. The two x's cancel out, and I can't apply the x to the y, so this y gets left alone. So when dividing by variables, the same variables can be divided. Different variables can't. So I can't touch my y because I'm not dividing by y, so it gets left alone. So in this case, pardon me, I put an x where I shouldn't. They both canceled out. So x divided by x just gives me 1, so then I'm left with 2y. To show a different example, a more spicy one, let's go 40 x squared y squared z minus 10 x squared y z plus 30 x y squared z, and then lastly 10 x y z squared. And we're going to divide by 5xyz. So again, what I want to do first, I'm going to split these up a little bit into columns, the 5, the x, the y, and the z, minus 10 over 5 x squared y z x y z plus 30 x y squared z over 5 x y z plus 10 x y z squared over 5 x y z. Okay, so I'm showing you this to kind of demonstrate a much more complicated one so that you can see where each of them, or where we can use our tools. So my first step, I've split it up. So I basically split this up into 4 different divisions rather than dealing with it all at once. There's nothing I can combine. And how I deal with these problems is I sort of think about these as separate values. So anything in between these columns, I'm going to divide by each other. That's why I gave myself a bit of space. So the 40 divided by 5 is going to give me 8. I'm sorry, let me extend these down so we can follow. So in this case, I have positives and negatives, so I can just bring these straight down. So x squared, the x on the bottom cancels out one of the x's on the top, so I'm left with 1x. The y cancels out with one of the y's on top, so I am left with a y. the z and the z cancel out, so I don't have anything. It's not 0, it's technically 1, but I'm not going to count 1 because 1 times anything is just itself. Oops, not mean to put 3 there. So there is an invisible 1 there, which I'm going to write, but I'm going to leave out. So it won't be my final answer. 10 divided by 5 is going to give me 2. This cancels out here with this one. So I have 1x. The y's cancel out, so I'm left with nothing. And the z's cancel out, so again I'm left with nothing. And again, these are 1s, not 0s. 30 divided by 5, so our next one gives me 6. X divided by x, so these actually cancel out now. This cancels out with this one down here, and then these two cancel out. So the only thing that I'm left with is actually a y in this case. And then the 10 and the 5 cancel, are reduced to give me 2. The x's cancel out, the y's cancel out, and the z cancels out with one of the z's. So I'm left with a z. So then, bringing this all together, kind of writing it a little bit simpler, I have 8xy, negative 2x, plus 6y, plus 2z. Now, one of the things, if this top part is already simplified, so if it's simplified here, you should be good down here. Notice how this is also simplified. I don't have to collect any like terms. They're all different, so I'm okay. And notice how also it is still from the highest degree to the lowest and alphabetical. So if your setup is good, it'll still carry through and be good after the fact. So that's another thing that's nice about having things in the proper order to start. It saves you steps down the line. Alrighty. So, believe it or not, this is as far as we go with dividing polynomials this year. The reason being, we don't actually have the tools yet to deal with larger divisions. You don't have to worry about this, but as a teaser, polynomials divided by polynomials is possible, but we need more tools. So as a teaser for grade 10, what you can kind of be expected to be, what kind of problems you could be expected to be doing. So a grade 10 example would be x squared plus 4x plus 3 divided by x plus 1. Now, I have actually set this up so that you could solve it. So if you're looking for an extra challenge, or if you're wanting to see what grade 10 has in store for you, try to get this as simple as possible. So this one, again, is a simplify problem. Basically, what you're trying to end up with is a polynomial of a smaller degree. Like, you've divided it into the smaller pieces. It's going to be hard, so this is sort of a challenge that I'm giving out, but it's not necessary. And again, we are skipping algebra tiles as a very quick how-to. It works the exact same way as multiplication, except you have your answer. Or if you were to do this as a multiplication, you have your answer and then you have one of your multiplying columns and you have to find the other. So you're sort of treating this as what times 2x equals negative 2x squared plus 4x. All right, so for exercises, for practice, what you can do, number 1, first column, number 2, first column. These are our milds. Following it up, they're still pretty mild, but you know what, I'll give them like a more spicy color to them. So A, C, E. These ones build on each other. So notice how we start with something simple and then we add another layer on it to it here, like there's a negative sign and then there's 2 negative signs. So these problems have a very similar pattern to them. Same thing, like these ones are all kind of the same. These ones are all kind of the same. These ones are all kind of the same. So if you can solve the easier one, try the harder ones. It just adds a few more rules and tricks into it. We are skipping 4. Don't worry about 4. This is our mediums. So notice how it gives you area. So you need to figure out this side here. And then for this one, volume, reminder, you are multiplying those 3 together and it gives you what the volume is. 6, perimeter. So keep in mind it's a square shape and it gives you the answer. So you have to find the length of each side. So use what you know about squares. This is where we start to get spicy. This is giving us a volume of a rectangular solid swimming pool. And then we actually go back to a medium spicy. 10. These ones are more of the same, except now they have additions included. So as a hint, solve each polynomial first, then add. These ones I would definitely say are medium. So what I mean by that is, you know what, I'm actually going to go over one of them just to show what I mean. So for here, I'm going to deal with this piece first, and then I'm going to deal with this piece. And notice how there's a division and a multiplication. Pardon me. So what I would do first is bring this negative in. So I would have negative 3x squared plus 6x minus 9. And I'm going to divide each of those by 3. So I'm taking 2 steps at once. I've split them, and I've also included the negative sign into both. Over here, I'm going to FOIL this through, and I'm going to include the negative sign. So this is going to be negative 8x plus 4x squared. Already you can see that once I get this fraction dealt with, it'll be way easier. So this one is going to be negative x squared. The 3's cancel out. Plus 2x minus 3 minus 8x plus 4x squared. And then as a reminder, I like to do my underlines. So there's 2 of them. Here's my wiggly ones for the x's. And then right there is my 3. So putting them together, I have plus 4x minus x. So this is going to give me 3x squared. Plus 2x minus 8x is going to give me minus 6x, and then lastly, negative 3. I'll give one more example. For question I, what I would recommend doing is solving the numerator first. It's going to make everything way easier, because right now we have 5 over 3 and it's just a mess. So my first step is to simplify both of these, so I'm going to leave them over 3. So I have negative 15x for my first term. Negative 5 times negative 6 is going to give me positive 30, and it's going to be x squared. Then here, negative 4x times 10x is going to give me 40x squared. My apologies, negative and negative give me a positive 20x over 5. Now from here, what I would do is see if I can reduce each of these. So negative 15x over 3 plus 30x squared over 3 minus 40x squared over 5 plus 20x over 5. So I'm not trying to find a common denominator, I'm trying to see if they simplify first. So negative 15x over 3, this is going to give me negative 5x. This one here is going to be 10x squared. Negative 8x squared, and then plus 4x. Lastly, looking for my like terms, I'll do it a little bit differently. I'm going to use a highlighter. So put together all the pink ones first. That'll give me 2x squared, because I've got a negative sign here. And then negative 5x plus 4x is going to give me negative x. So my final answer simplified is going to be here. And that's how you solve these kind of problems. So what you'll notice is I deal with the top part first, then I treat the negative signs, then I treat with the divide signs, and then I get them as simplified as possible, and then last step is I collect like terms. Don't try to add between fractions for now, because trying to find a common denominator is much more of a pain than if you can just simplify it. And that's all, because if you notice, the next page is chapter review. So for sure, give these ones a try. They definitely get spicy as they come down here, so this one is definitely more of a spicy question. But I do highly recommend trying them. The more familiar you are with these slightly difficult questions, the easy ones will just take you like 2 seconds to see. And so once you get really, really handy with the more complex ones, everything else kind of becomes trivial. So that's all I have for you today. Take care, stay safe, have a good one. Keep an eye out for our check-ins, for our assignments. Remember, all this stuff is also going to count towards our marks, and there's going to be very little time to actually review. We're going to basically jump right into a test when we get back. So keep that in mind. It's still important to stay on top of this, even though we are during a remote lesson. That's all I have for you today. Stay safe, have a good one.